Before going any further, a direct correction, because getting this exactly right actually matters for understanding what genuinely happened. No SpaceX Lunar lander crashed on the moon this week. SpaceX has never landed a spacecraft on the moon at all, and its Starship human landing system, still under development, has not yet flown anywhere near it. What actually happened on Wednesday, August 5th, 2026, was considerably stranger than a simple lander crash, and in its own way, more genuinely interesting. A discarded, empty rocket stage, leftover hardware from a mission launched more than a year and a half earlier, silently drifted through space, unnoticed and untracked for months, before finally slamming into the lunar surface at more than 5,400 miles an hour. An impact astronomers had actually predicted down to the exact day, months in advance. This is the real story of what struck the moon this week, the two very different lunar landers it originally helped carry there, and why an ordinary leftover piece of space hardware managed to capture global scientific attention on its way down. To understand what actually happened, you first need to go back to January 15th, 2025, when a SpaceX Falcon 9 rocket lifted off from Kennedy Space Center in Florida, carrying not one but two entirely separate, unrelated lunar landers stacked together on the same launch. The first, Firefly Aerospace's Blue Ghost Mission 1, went on to become one of the genuine success stories of the current wave of commercial lunar exploration, touching down safely on Mare Crisium on March the 2nd, 2025, and remaining for a considerable stretch of time afterward, the only fully successful mission flown under NASA's Commercial Lunar Payload Services program, an initiative specifically designed to have private companies, rather than NASA itself, build and operate the actual spacecraft delivering scientific equipment to the lunar surface. The second lander riding alongside it, Resilience, built by the Japanese company iSpace, followed a considerably longer, more roundabout trajectory to the moon and met a very different fate. On June 5th, 2025, during its own attempted landing, Resilience's laser rangefinder failed, and the spacecraft crash-landed on the lunar surface. iSpace's second failed landing attempt after an earlier, similar failure back in 2023. Takeshi Hakamada, the company's chief executive, addressed the loss directly at the time, describing the mission as merely a stepping stone toward a larger lander the company has planned for 2027, one that will involve NASA collaboration, while acknowledging plainly that engineers had done everything they possibly could to try to ensure the mission's success. Both of these separate, unrelated landers had relied on the same Falcon 9 upper stage, the discarded top portion of the rocket, to carry them away from Earth and out toward the moon during the earliest phase of their journeys. Once that job was finished, the upper stage was supposed to simply fall away and become irrelevant, following the same basic pattern almost every rocket stage used for a deep space mission typically follows, entering a wide, elongated orbit around Earth, before eventually being pulled back down by atmospheric drag and burning up harmlessly on re-entry. This particular stage did not do that. For reasons that remain somewhat unclear even now, it avoided re-entering Earth's atmosphere during its closest approaches, and instead settled into an unusual, persistent orbit that brought it gradually closer and closer to the moon with each successive pass. On April 29th, 2026, an astronomer named Bill Gray, who has built a considerable reputation specifically for tracking exactly this kind of derelict, hard-to-categorize space debris, identified this specific object and calculated something remarkable: the precise date, time, and location at which this abandoned rocket stage was going to collide with the moon. His prediction held. NASA confirmed the impact occurred at 2:35 in the morning on Wednesday, August 5th, 2026, striking the lunar surface near the Einstein crater, a location on the moon's far side, at a velocity exceeding 5,400 miles an hour. The stage itself weighed an estimated 4 tons, roughly 8,818 pounds, and NASA officials confirmed the impact was expected to carve out a fresh crater approximately 60 feet wide and 12 feet deep, throwing a plume of pulverized lunar dust and rock outward as ejecta in the process. What happened next turned this leftover piece of space hardware into a genuinely significant, actively studied scientific event, rather than simply a piece of unfortunate space junk quietly disappearing without anyone taking much notice. Astronomers across the Americas, positioned in the best location on Earth to actually witness the impact directly, aimed both ground-based and space-based telescopes toward the predicted impact site well in advance, hoping to capture the collision as it actually happened. The European Southern Observatory's Very Large Telescope, located at the Paranal Observatory in Chile, successfully detected the impact directly, and Barbara Ferreira, media manager for the observatory's communications department, confirmed the specific scientific result that came out of that observation. The telescope detected clear spectral lines of both sodium and lithium gas within the resulting impact plume, persisting for somewhere between 5 and 10 minutes following the collision itself. Ferreira explained the likely origin of each specific element found in that plume: noting that the sodium most likely originated directly from the lunar soil itself, disturbed and vaporized by the sheer force of the impact, while the lithium detected in that same plume could plausibly have come from the rocket stage's own physical structure and materials. In the days immediately following the impact, additional observations began confirming exactly what the collision had actually left behind. South Korea's own lunar orbiter, positioned favorably to examine the impact region, became among the first spacecraft to successfully capture and return images documenting the aftermath, revealing a genuine, freshly formed crater precisely where astronomers had calculated it would appear. Scientists studying these results have noted that analyzing the specific scale of the resulting blast and the precise size and shape of the crater it actually produced can yield genuinely valuable scientific data, helping researchers refine their understanding of the underlying gravitational and geological physics governing how impacts of this general size and speed actually behave when they strike the moon's surface. It is worth pausing to note something that NASA itself was careful to emphasize when this story first broke, precisely because the framing of a man-made object crashing into the moon can sound considerably more alarming or more unusual than the underlying reality actually supports. A NASA official directly addressed this point, explaining that there is no danger whatsoever to Earth from an impact like this one, and noting, as useful context, that a meteoroid carrying roughly the same amount of kinetic energy as this specific rocket stage actually strikes the moon, on average, about once every 6 days. In other words, while a large, identifiable, human-made object crashing into the lunar surface understandably attracts attention and generates headlines, the moon itself is subjected to impacts of genuinely comparable scale on a remarkably routine basis, simply from ordinary, naturally occurring space debris that nobody tracks or predicts in advance, since none of it originated from a known, cataloged human spacecraft in the first place. This event also connects to a considerably longer ongoing history that stretches back to the very earliest days of the entire space age. Humanity has been placing man-made objects on the lunar surface, whether intentionally or not, since September 13, 1959, when the Soviet Union's Luna 2 spacecraft completed a roughly 36-hour journey from Earth and performed a deliberate, planned crash landing between two prominent lunar features known as the Sea of Rains and the Sea of Serenity, becoming the first human-made object in history to ever reach the surface of another world. In the more than 6.5 decades since that first intentional impact, the moon's surface has steadily accumulated a considerable collection of both successful landers and unintended crash sites, spent rocket stages, discarded equipment, and occasionally, as in this specific case, entire abandoned upper stages that simply drifted for years before finally, predictably, coming down. What makes this particular event genuinely notable within that much longer history is not that a piece of space hardware struck the moon at all, since that has happened many times before, both intentionally and by accident. What makes it notable is the specific combination of factors surrounding this exact impact. An object whose precise trajectory and eventual collision date could be calculated and publicly predicted months in advance, giving the global astronomical community a genuinely rare opportunity to prepare in advance and actually observe a lunar impact as it happened in real time, rather than simply discovering evidence of a collision after the fact through later orbital imagery. This kind of advanced predictability turned what might otherwise have been an unremarkable, quietly forgotten piece of space debris into a genuine, actively studied scientific event, contributing real data about impact physics and lunar surface composition, gathered specifically because astronomers knew exactly where and when to look. It is also worth being direct about why this story likely generated the specific kind of confused, inaccurate headlines that prompted the need for this correction in the first place. This particular rocket stage had, after all, originally been responsible for carrying 2 genuine lunar landers on their way toward the moon, one of which, Resilience, had itself already landed on the lunar surface just 2 months after that same January 2025 launch. In the retelling and resharing that inevitably follows any space-related news story, it is not difficult to see how these two genuinely separate events, ISpace's Resilience lander crashing in June of 2025, and the same mission's leftover rocket stage separately crashing more than a year later in August of 2026, could become conflated into a single inaccurate claim about a SpaceX Lunar lander crashing, when in reality, SpaceX has never actually operated a lunar lander of its own at all, and the object that genuinely did strike the moon this week was simply a piece of already discarded empty rocket hardware, doing exactly what discarded rocket hardware eventually does when its orbit happens to intersect with a large enough gravitational body. Looking ahead, the same broad period of lunar exploration remains genuinely active, with several additional missions currently planned or already underway through the remainder of 2026. Blue Origin is preparing to attempt its own first moon landing using the Blue Moon Mark 1 cargo lander, targeting the lunar South Pole, Intuitive Machines is preparing for its own third lunar landing attempt, aiming for a region called Reiner Gamma, following 2 previous missions that each ended with their respective landers tipping onto their sides after touchdown, hindering, though not entirely preventing, their planned scientific operations. Additional missions from Astrobotic Technologies and a second Firefly Aerospace lander are also in various stages of planning, part of a broader, sustained push by NASA to establish reliable, repeatable commercial access to the lunar surface ahead of its own planned return of American astronauts later in the decade. So here is the honest, complete picture behind what actually happened at the moon this week. No SpaceX Lunar lander crashed, because SpaceX has never landed a spacecraft on the moon at all. What genuinely happened was the long-anticipated, precisely predicted impact of an abandoned Falcon 9 rocket stage. Leftover hardware from a January 2025 mission that had originally carried 2 entirely separate lunar landers toward the moon, one of which succeeded, and one of which had already crashed on its own more than a year earlier. That same rocket stage, drifting quietly and unpredictably through space in the time since, finally struck the lunar surface on August 5th, 2026, in an impact astronomers tracked and predicted months in advance, giving scientists around the world a genuine real-time opportunity to study exactly what happens when a 4-ton piece of human-made hardware collides with the moon at more than 5,000 miles an hour. If you want to see what the ongoing analysis of this impact site eventually reveals, and what the next wave of lunar landers currently on their way to the moon actually finds when they get there, subscribe and turn on notifications, because 2026 is proving to be one of the busiest years in lunar exploration history. And this was only one part of a considerably larger story still unfolding.